Very good day, Dr. Noor. We are from Group 1 of Section 4 and we will be presenting about our project which is off-grid photovoltaic system. So I am Ishwajit Singh, matrix card number CE200095, and with me my group members are Nurman bin Senu, Muhammad Iqbal Afiq bin Muhammad, Amirul Haziq bin Jafri and Praveen Raj Anak Kanan. I will just explain the four parts which is abstract, introduction, problem statement and the objective. So, abstract, solar power systems are one of the greatest renewable energy technologies since they are cost effective and also environmentally good. This system can be labeled as an off-grid photovoltaic system since all energy are stored and used at a certain location, for example, residential. A photovoltaic system can capture solar energy and use it to create electricity by the usage of the PV cells. And the potential of the system shines especially during the situation where there's electricity outage. So for example, when there is a outage at night and you need to use some appliances, you can just take the energy required from this off-grid photovoltaic system. The purpose of this research is to describe the design of a photovoltaic system and create a proposal for standalone off-grid photovoltaic system for Mr. Ahmad Nisfu Residential. Introduction: converting the energy from the sun uh, to electricity is the first step in harnessing solar energy by usage of photovoltaic cell. One of the popular PV system that is used is standalone off-grid system. It implies that there are solely accessible source of electricity. Basically, they can run as mini grid to generate power when needed for their appliances. Appropriate for small settlements or to cover a certain percentage of your load. This off-grid system includes PV panel and inverter, battery storage, and additional components like some transformer. The This project feasibility is having an off-grid power system that can power and support the demand and needs of the residential house that belongs to Mr. Aman Nisfu. It can also be used on a wider scale depending on the residential by taking note of the installation, for example, the usage of the cable size and etc. Problem statement. There are three problem statements for our project. First would be the what is an alternative solution for lack of electricity resource, how to design self-sufficient off-grid photovoltaic system to work efficiently, and how to utilize the photovoltaic system to the fullest and support the demand of daily application. The objective of our project research paper is to design an off-grid photovoltaic solar system for residential house, like Mr. Ahmad Nisfu house, to construct an off-grid photovoltaic solar system that is capable of delivering around 100% of the electricity demand required by the resident. And lastly, to provide the homeowner with a sustainable and long-term saving plan with clean energy.
Okay, Assalamualaikum and hi. So for my part, for first we go to the methodology. Solar cells convert sunlight into electricity directly. Calculators and watches are frequent powered by solar cells. They are made of semiconductor materials utilized in computer chips. When these materials absorb light, the solar energy loosens electrons from their atoms, allowing them to move through materials and produce electricity. Photovoltaic effect is the conversion of light photon to electric voltage. Solar cells are actually integrated into modules with 72 cells, and several of these modules are installed in PV arrays that can be several meters long. Solar cells are built of the same semiconductor material used in the microelectric sector, such as silicon. A tiny semiconductor wafer is particularly processed for solar cells to create an electric field that is positive on one side and negative on the other. Electrons are knocked loose from this atom in the semiconductor materials when light energy impacts the solar cells. The electrons can be caught in form of an electric current, that is electricity, if electrical conductors are coupled to the positive and negative side, producing an electrical circuit. After that, the electricity can be utilized to power loads such as lamp or tool. So next we will go to the types of solar PV installation. So there are two types of solar PV installation, which is off-grid and on-grid. Solar system that are connected to the grid or known as on-grid are by far the most popular and commonly used by home and businesses. These systems do not require batteries and are powered by solar inverters or micro inverters. They are also connected to the power grid. You normally get paid for FIT or known as feed-in tariff or credit for any extra solar power you create when you export to the electrical grid. Because an off-grid system isn't connected to the power grid, a battery storage is required. So for this experiment, uh, no, for this project we use mainly off-grid solar system. So off-grid solar system must be designed properly to generate enough power throughout the year and have enough battery capacity to meet the home needs even in the of when winter when sunlight is insufficient. Off-grid systems are much more expensive than on-grid system due to high cost of battery and off-grid inverter. As a result, off-grid systems are usually only needed in more remote areas far from the electrical grid. So the difference between off-grid and on-grid solar panel, as we can see here. So for on-grid solar PV installation, we have solar panel, inverter, utility meter, and grid. While for off-grid, we have solar panel, inverter, battery bank, and the most important thing that we need to have in off-grid solar PV installation is battery bank. So next we go to the component of off-grid photovoltaic system. So for the first we go to photovoltaic solar panel. Solar panel collect clean renewable energy in the form of sunlight and convert that light into electricity which can be then be used to provide power for electrical loads. Solar panels are comprised of several individual solar cells which are themselves composed of layer of silicon, phosphorus and boron. Solar panels absorb the photons and in doing so initiate the electrical current. The resulting energy generated from photons striking the surface of solar panel allow electrons to be knocked out of their atomic orbits and released into the electrical field generated by the solar cell, which then pull these free electrons into a direction. Okay, next we will go to the battery. So for battery, we have a various type of solar PV battery such as lead acid battery and lithium ion battery. So off-grid solar system need the use of specialized off-grid inverter and battery system that are capable of storing energy for at least 2 days. Hybrid grid connected system make use of lower cost hybrid battery inverters and only require a battery that can deliver energy for 5 to 10 hours overnight depending on the application. So as we can see here, there are various types of off-grid solar system PV battery bank. So next we will go to the inverter. So solar panels provide direct current DC electricity which must be converted to alternating current AC for usage in our homes and businesses. The solar inverter principal function is to accomplish this. So as we can see here, is the diagram for solar PV inverter installation, which is from solar panel it will give direct current to solar inverter, and then from solar inverter it will produce AC current into home appliances. So the next of it is the picture of an example inverter. And next we go to the controller. A solar charge controller protects the solar battery from overcharging by acting as a regulator. Battery have a voltage capacity rating that exceeding that voltage can result in long-term battery degradation and loss of performance. Solar charge controller operate as a gatekeeper for battery storage system, ensuring that it is not overloaded. It ensures that deep cycle batteries are not overcharged during the day and that the power doesn't run backwards to the solar panel overnight and drain the battery. So for solar charge controller, we can see the picture of an example solar charge controller, and the next of it is the wiring diagram for solar charge controller. And next we go to the methodology diagram. So this diagram show on methodology on how we solve this problem. So for the first, we make some research about an off-grid PV system, and next we find all the components that needed to be in the off-grid PV system. Next we do the manual calculation for load analysis, number of PV panel, battery sizing, and also solar charge controller. And the next we started to do the simulation based on manual calculation information that we get using the PVSys software. Next is we take all the results consist of cost analysis from the simulation calculation in the PVSys simulation. And next is discuss the result that we get and list the environmental effects of this off-grid system. And for the last, we do the conclusion. So that's all for the methodology.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nama Bisnu DE190173, and today I will show how to do the manual calculation for Encik Ahmad to design his off-grid network system using a PV panel. Now, the first thing that we need to do is we need to identify and list out all of our equipment needed for Encik Ahmad house. So, from the table, we have listed all the very important equipments for his house, and we need to decide what is the power and the quantity needed for his house. So after we have gained the power and quantity, we must find the total power for each equipment. After that, we must identify how many hours that each of the equipments works. So for an example, for LED light, Encik Ahmad will use only for 8 hours during the night. So, after we find the total power, we must multiply it with hours, and we will find the power consumption for Encik Ahmad house. So, for Encik Ahmad house, we have calculated it, and the total power consumption for his house is 8,216 watt per hour. After we have find the power consumption, we must determine our sizing of our battery bank, of our solar PV panel. So, we have choose a 380 watt, 48.8 volt, 9.94 ampere with 19.5% efficiency, while the sun peak at Encik Ahmad residential is 7 hours. So, the PV power for our solar panel is 1534 watt. So the number of PV panels that are needed for Encik Ahmad house is 4. Now, for the battery bank, we choose a 12 volt 215 AH, 15% DOD, and with efficiency of 85%. So for our system voltage, we use 48 volt because our power consumption has exceeding the limit, so we must use a 48 volt system voltage. After doing some calculation, we will get our battery bank capacity is 404.9 AH, and the number of string for our battery bank is 2, and the number of series is 4. After that, we must calculate the sizing of our inverter. So from the load equipments, we will find the power and the quantity for each equipment. So after that, we must multiply the total power of each equipment with a multiplier. So for this case, some of the equipment we only multiply it with 1.3, but for some equipment, such as equipment with motors, we must multiply it with 2 or 3 according to its equipment. So, for our inverter, we choose a 3 kilowatt, 48 volt, and 16 ampere because our total power is 2711.8 watt. So we still can use the 3 kilowatt inverter because it not exceeding our actual total power. After that, for the solar charge controller, Encik Hamad have chosen the PV panel that we have tell earlier. So for the solar PV connection, for its series and string, the number of series solar PV panel is 4, while the number of string for the PV panel is 1. So the current CC for the current for the solar charge controller is 12.425 ampere. Now we have calculate all the important things that are needed for Encik Hamad house. So for the last part for this design is to determine the circuit breaker for DC and AC of the system. So for circuit breaker 1, we must use a 12.425 ampere, while for circuit breaker DC2, it's same as the value of ICC, so we use 12.425 ampere. Now, for the third DC circuit breaker, we must calculate it by using P rated divided by system voltage. So our P rated is 3 kilowatt and our system voltage is 48 volt. So we need to use a DC circuit breaker of 62.5 for the third circuit breaker. And for our AC circuit breaker, we only use 13.64 ampere. So that's all the importance value and parameters that are needed for Encik Hamad house. So we will show it in our simulation to determine our result of this load design. So that's all from me. Thank you.
Assalamualaikum, my name is Anwar Haziq bin Jeffrey. My metric number is AE190038. Today I will talk about our project for generation, transmission and distribution project. For this project, my part is to do a simulation to show how much the house needed for the generations. Then for this project we use PVC 7.2. To use this project, first we need to name the project. As we can see, the name of project is Project Solar on Mr. Ahmad Nisfu House. And after that we need to find a site file that I have found on the Google Earth, and then for the Meteor file, and after we put this tree, we can do the variant. So for the variant, first we need to open the orientations. For the plane tilt, we use 25 degree, and then for the azimuth is 0. So you can see that the tilt and the azimuth for the orientations. And after that we can go to users need. As we can see here, the appliance got lamps, TV, PC, mobile, domestic appliance, fridge, deep freeze, dish and clothes washers, and other use. For the lamps, number for the lamps is 12, and then for each lamps need 9 watt, and the daily use for the lamp is 8 hours per day. So for the daily energy is 864 watts. And then for the TV, PC, mobile, it has only 2. For each needed 80 watt power, and daily use for 6 hours per day, and then we can get 960 watt per hertz. After that, domestic appliance have 4, and then the power is 75, 10 hour per day, and then we can get 3000 watts. For fridge is 200 kilowatts per hertz, 10 hours per day daily use, and we can get 20,000 watts. And for dish and cloth washer, same, only one. We use only 250 watt average for 2 hours, and we can get 500 watt. And for the other use, once for 100 watt for 3 hours per day, we can get 900 watts, and for 6 watt we can get 336 watt hours. And total daily energy is 284 watts per day, and monthly energy is 600. Monthly energy is average for 6,188.5 kilowatt per hertz. This is for the user's need. And then we can go to the system. For the system, we use MPPT converter, that is 1000 watt, 102 volts, 732 ampere, and 240 ampere. And the anticipated PLOL is 5%. Mode in series is 4, number strings 46, and we can get the user's need household average power 8.6 kilowatt, daily energy 206 kilowatt per hertz, capacity for the battery pack, PV array, and the controller. And for the detail loss, is constant loss factor you see is 29 watt per meter squared, and wind loss factor is 0. Same for the others. For the ohmic losses, module quality, soiling loss, IEM losses, and spectral corrections. For the ohmic loss, fraction at STC is 1.50, module efficiency loss is negative 0.5, and power loss at MPP is 2.0. Soiling loss yearly is 2.0, and here is the graph for the IEM losses. And for the spectral correction, here's the spectral correction. And for the horizon, we can see the line drawing legal time, fixed plane, tilts azimuth for 25 degrees. It's like this. And then after that, we can proceed to the simulation to run. So we can run the simulation. So we can see it has a daily input output diagram graph, performance ratio PR, solar fraction, array power distribution, and array temperature versus effective irradiance. For the performance ratio, it is around 68%, and for the solar fraction is around 96.8%. And as you can see here, the system production is 87.7 megawatts. Normalized production is 2.93 kilowatts per hertz per day. Specific production is 1288 kilowatts. Array losses 1.06. Performance ratio is 68% less, and system losses is 0.32 kilowatts per hertz per day. That's all from me. Thank you.
Hi, greetings to doctor. My name is Pravindra son of Kannan, and my matrix number ID is CE210 and 202. So today I want to talk about my part in the project report, that is discussion and conclusion. Let's go. So for discussion and conclusion, what we have discussed is that about the photovoltaic system for the Aman Nitsus-O. So to design the reliable SFU system, it is necessary to identify the crucial data that has influenced the system's performance. The data for this investigation was separated into two categories: site installation location and total energy consumed by the requirement loads. Both of these pieces of information have a significant impact on the creation of an economic system. The selection parameter of every component is very important to fulfill the system configuration. All components selected based on the energy requirement of the load demand and the potential of meteorological data of site installation. The sun's energy is manifested as a radiation. PV array size is determined by the amount of solar radiation available. Arrays are made of the large number of solar module joints together. So finally, for this discussion, in this study we discussed the PV system software simulation tools used to analyze the SAPV system. The software allows PV solar system designers to design system configuration as well as participate energy production. Based on the simulation of the sizing system, the output was generated. The size system is highly dependent on the geographic location of the site. This research centered on the SAPV system, which was utilized to off-grid photovoltaic system for a residential house that belongs to Mr. Ahmad Nifsus. To meet the load demand, 4 PV modules with a rating of 380 watt each was chosen. As a system, 4 number of series unit of 250 Ah batteries were used. So this is the detail of the PV system component on Mr. Ahmad Nifsus house. So we use PV panel of 4 number of unit, battery 4 number of series batteries, and inverter and the solar charge controller. Also we provide the specification of the components, and doctor can see that. And this one is Mr. Ahmad Nifsus off-grid PV system design. So this is the design we made, and this is the software we using for the simulation, PV system simulation. And for the conclusion, what I can conclude is, now home workers are looking for a new energy solution as energy bills continue to climb and environmental concerns continue to grow. Off-grid photovoltaic systems were first utilized to generate power for basic daily necessities like lights, TV, and radio in isolated villages, farming areas, sea islands, and other remote areas. When off-grid PV system initially became available to homeowners, the initial expenditure was a little daunting. With the lower cost of the essential components, an off-grid photovoltaic system is now practically option, providing homeowners with a new long-term saving strategy and clean energy. An off-grid PV system can be useful in a variety of contexts and applications. Whether or not you desire to live off the grid, you don't use any water, emit no pollutants, and don't have to pay any monthly electricity bills with off-grid PV systems. So that's all from me. Thank you.